Hello, welcome to my channel. Maths Made Easy with Terry in 10 minutes, just 10 minutes, okay? We're gonna talk about integrating partial fractions with linear factors, all right? So we talked about how to integrate or review last video, so please go back and have a look. So we're gonna quickly just jump into it because we have two examples to solve here today. So in the last video, I showed you with partial fraction how to get this, which was x squared minus 3x plus 2. And from the video, we found it to be 3 over x minus 2 and minus 2 over x minus 1. All right, so if you missed the last video, please just go back to the last video and you just see how we got these answers. Now we're meant to integrate this. And with partial fraction, we broke this into this fraction into this prime numbers, 3 over x minus 2 and 2 over x minus 1. And we're meant to integrate them. All right, so applying the same rule, okay? So we're integrating x plus 1 divided by x squared minus 3x plus 2. We integrate to bring the 3 out, and it's going to be 1 over x minus 2 minus, we bring the 2 out, it will be 1 over what? X minus 1. As you can see, the value you have here, we're going to apply this the ln here. If you remember one of the video I talked about, f of x divided by f prime is equal to the ln of f of x plus c, okay? Integral forms, please go to the video. We talked about integral forms here. So you can see this follows the rule here. So that means the answer is going to be 3 ln x minus 2 minus 2 ln, oh, sorry, I wrote this wrongly, minus 2 ln x minus 1 plus c. And that will be the answer for this, okay? All right, let's solve another question then. So this was from the previous one. Let's solve another one. Another example I have here, I have x divided by x squared plus 3x minus 4. Okay, so the first thing, I'm going to break this into partial fractions. And this is thing I'm saying x all over, based on quadratic, this will be x plus 4 and x minus 1. And this is going to give you a all over x plus 4 plus b over x minus 1. Now, I have to use partial fractions here to get what a and b is. So by partial fractions, it's going to be x is going to be equal to a x minus 1 plus b x plus 4. Okay, so I will say let x to be equal to 1. So this will cancel out. So that means 1 is going to be equal to 5b. So therefore, b is going to be 1 over 5. Now the next one, I can say let x be minus 4 so that this will cancel out here. So we have it there. So let x to be equal to minus 4. So minus 4 plus 4 will give you 0. This cancels out. So it will be minus 4. Okay. So minus 4 will be equal to minus 4 minus 1 will give you minus 5a. Okay. So therefore, you divide both sides by minus 5. So therefore, a is going to be equal to 4 over 5. Because if you divide both sides by minus 5, okay, can you see? This will cancel this, and you're left with minus 4 over minus 5. Minus cancel minus be plus, and you give it 4 over 5. So that means I can rewrite this again to be, okay? I can write this again to be that x all over x plus 4, x minus 1 is equal to a is what? 4 over 5 divided by x plus 4 plus b is what? 1 over 5 divided by what? X minus 1. So, and this can be written as 4 over 5 is the same thing as saying, so we're integrating right? We're integrating each of them. So it's I say 4 all over 5x plus 4 plus 1 over 5x minus 1. So as usual, you bring out the constant. So that'll give you 4 over 5 into 1 over x plus 4 plus 1 over 5 into 1 over x minus 1. So now you can see this agrees with the lean form that we talked about in my previous video, where we talked about the integral forms. One of them we talked about was that f prime of x divided by f of x is equal to the lean of f of x plus c. So that means this follows the rule. So I can now say it to be 4 over 5. So please, if you've not looked at my previous video on lean, on the integral form of f prime over x, f prime x divided by f of x and the product as well. So I talked about this. I also talked about the product as well, okay, of this as well, of the both integral forms. So I talked about this in my previous video. So you need to go back and have a look, okay? Then this is going to give you lean x plus 4 plus 1 over 5. And you're going to give you lean x minus 1 plus c. And that will give you the answer for that. Okay? So please ensure that you go back and have a look, okay? So this is for linear factors, okay? The next one I'm going to be talking about, the next video I'll be talking about is how to integrate the ax plus b squared factor. That's the next video I'm talking about now. I'm going to go and talk about. So please, a classical example could be something like x squared over x plus 1, x minus 1 squared. When you're told to integrate something like this, what do you do? Okay, now this is different. What we just talked about was a linear factor when you have something like this. But when you have an ax+b squared factor, something like this, what do? It's still the same thing, but it's just slightly different based on the partial fraction we talked about in the previous video, okay? All right, thank you very much. So that is that for that. Okay, so quickly, the same way you'll solve a normal partial fraction, you break it down to the partial fraction and get the values for the a and get the value for the b. You put it down, and then you now apply the integration formula and principle as well. Okay, thank you very much, and I'll see you in the next video. Please don't forget to subscribe and like so that you get notification when I post new videos. All right, thank you very much and have a nice day.